Welcome and good morning to all. Myself, Pulok Rai. In first lecture, I have already discussed atomic structure. In atomic structure, I have already discussed the Rutherford's atomic model and its drawbacks. Then Bohr came, that is Bohr's atomic model, Bohr's merits and demerits, that is advantage and disadvantage of atomic model. Then came de Broglie, that is de Broglie concept. Bohr, in his theory, he has assumed that electron is a particle material revolving round the nucleus in a circular orbit. But in 1924, de Broglie pointed out that an electron like light exhibit wave as well as particle nature, that is, electron has a dual character. In de Broglie's concept, it gives an idea about the wave mechanical theory of matter. De Broglie derived an expression for the calculation of wavelength of the wave associated with particle mass m and moving with velocity v. He expressed equation as lambda equal to h by mv, that is h by p, where p equal to mv, where lambda equal to wavelength, m equal to mass of an electron, v equal to velocity of electron, that is lambda equal to h by p. Although de Broglie's concept is applicable for materials, particles, that is moving, whether it is small or large, but actually it is significant for the very large particles like electron and insignificant for the large particle. But in such case, the wavelength, de Broglie's wavelength is too small to measure. Actually, although the de Broglie's concept is true for particle which is moving, whether it is small or large, but actually it is significant for the very small particles like electrons and insignificant for the for large particles, because in such case de Broglie's wavelength is too small to measure. Then quantum numbers. What is quantum numbers? The numbers used for completely characterizing, for completely characterizing of each electron of an element. The numbers used for completely characterizing of each electron of an element are called quantum numbers. Are called quantum numbers. Four such quantum numbers are necessary to found for describing electron of an element. Their first principal quantum number, second azimuthal quantum number, third magnetic quantum number, and fourth spin quantum number. The first principal quantum number, it is denoted by small n, and it was proposed by Bohr. It determines the average, the position of electron. It determines the position of electron around the nucleus. It determines the position of electron around the nucleus and size of the orbital. It determines the position of an electron around the nucleus and size of the orbital. Higher the principal quantum number, the greater is its distance from the nucleus, the higher is its energy, and the greater is its size. The principal quantum number actually determines the average position of the electron around the nucleus. Although its theoretical value may be 1 to mu, but actually 7 values so far, 1 to 7 values, 1 to 7, actually theoretically its values range from 1 to mu, but actually 1 to 7 values have so far been established, It is represented as either 1, 2, 3, 4, 5, 6, 7 or K, L, M, N, O, P, Q respectively. 1 to 7 values have so far been established. It is represented as either 1, 2, 3, 4, 5, 6, 7 or K, L, M, N, O, P, Q respectively. The number of electrons in the principal, maximum number of electrons in the principal quantum number is given by 2n square, is given by 2n square. When n সমান 1, when n সমান 1, when n সমান 1, that is k orbit. When n সমান 2, when n সমান 1, the maximum capacity of electron is 2, that is k cell. That is k cell. When n সমান 2, its maximum capacity 8 electron, that is L cell. And then azimuthal quantum number. It was proposed by Summerfield. It was proposed by Summerfield. And it is denoted by small l. It was proposed by Summerfield. It is denoted by L. The main energy levels are divided into sub energy levels and is designated as azimuthal quantum number. The main energy levels are divided into sublevels. And are designated as azimuthal quantum number. Azimuthal quantum number. And it is denoted by small l. Azimuthal quantum number describes the shape of the orbital occupied by the electron. It determines the shape of the orbital. It determines the shape of the orbital occupied by the electron. It determines the shape of the orbital occupied by the electron. For a given value of the principal quantum number, for the given value of principal quantum number n, azimuthal quantum number may have all integral value from 0 to n minus 1. For the given value of principal quantum number, the azimuthal quantum number, that is L, may have all integral values from 0 to n minus 1, each of which represents the sublevels or sub-energy levels of or sub energy levels. Sub energy levels. And these are designated and these are designated as and these are designated as these are designated as S, P, D and F. Today I discuss up to azimuthal quantum number, and next I will discuss from magnetic quantum number. Thank you very much.